Fungi have existed as the planet's primary decomposers for millions of years. They are biologically hardwired to break down dead organic matter. To execute this function, they reproduce by releasing microscopic spores. These spores are permanently suspended in the air columns all around us, drifting constantly through both outdoor environments and interior spaces. Over the last few decades, construction practices shifted toward energy efficiency. We built tightly sealed building envelopes to save power. But without adequate ventilation, these airtight structures trap incoming air and moisture inside. When that trapped water vapor accumulates, a standard residential or commercial space stops being a shelter and effectively becomes an optimal microbial incubator. The end stage of this incubation is severe. The biological mass compromises occupant health and triggers aggressive structural decay across wood framing and drywall. Modern construction methods do not inherently prevent these fungal attacks. Often, they merely conceal the growth within wall cavities and ventilation shafts until the physical damage is catastrophic. To understand this vulnerability, we have to look at how these organisms feed. Fungi are saprophytic organisms. They survive by secreting enzymes to externally digest dead organic matter, absorbing the simplified nutrients. Inside the built environment, their preferred organic matter is cellulose. This saturates our standard building materials, specifically structural wood studs and the paper facing a drywall. To protect a building's structural integrity, we must isolate the specific biological triggers that awaken these spores, map the pathways of moisture intrusion, and execute precise preventative protocols. Because our buildings are inherently constructed out of the very food sources these organisms require, we cannot defend our infrastructure through material starvation alone. Fungal proliferation requires 4 specific conditions: nutrients, oxygen, optimal temperature, and moisture. We cannot eliminate the nutrient supply. Cellulose is abundant, and even on non-porous surfaces, accumulated dust provides enough organic material to sustain a colony. Oxygen is equally impossible to remove from occupied spaces. Fungal species thrive between 40 and 100 degrees Fahrenheit, perfectly overlapping the human comfort zone. Keeping buildings comfortable makes them hospitable for spores, taking thermal manipulation off the table. This leaves moisture as the absolute controlling factor for indoor fungal growth. With oxygen, temperature, and food acting as fixed constants, mastering moisture control is the only mathematical way to win the hygrothermal equation. Water enters and persists within a building envelope through 3 distinct physical mechanisms. The first is bulk water intrusion. This is visible, liquid water entering through compromised roofing systems, deteriorated exterior flashing, or internal plumbing failures. The second mechanism is capillary action. This is a natural wicking force that draws ground moisture upward through porous masonry and concrete foundations. In slab-on-grade construction, this continuous upward draw forces moisture to accumulate underneath floor-level materials, quietly saturating carpet pads from below. The third mechanism is vapor diffusion and infiltration, an invisible atmospheric threat driven by air pressure and humidity. When an HVAC system depressurizes a building, it creates a vacuum effect, pulling moisture-laden outdoor air through microscopic cracks in the envelope into cooled interior spaces. While bulk water leaves obvious signs of damage, capillary action and vapor infiltration secretly saturate the building's structural defenses from the ground up. It is widely assumed that fungi require standing liquid water or an active leak to germinate. They do not. The danger stems from a thermal bridge, a localized cold spot like an uninsulated wall corner. When warm, humid indoor air contacts this cold bridge, it cools rapidly. Because cold air holds less moisture, relative humidity at that exact point sharply spikes. Maintaining relative humidity above 70, the germinated spore develops branching hyphae to extract nutrients from the substrate, expanding into a dense, visible mycelium network. Finally, the colony enters sporulation. The mature fungal mass releases thousands of fresh spores directly into the HVAC system, allowing the organism to colonize new territories across the building. This entire life cycle, from dormant spore to active sporulation, completes in 24 to 48 hours. Speed is the primary variable in damage mitigation. To defend against this biology, the primary systemic objective is to continuously maintain indoor relative humidity between 30 and 50%. Achieving this requires strict mechanical oversight. Building managers must ensure proper HVAC pressurization to prevent infiltration. paired with advanced continuous dehumidification systems. Routine HVAC maintenance is mandatory. Drip pans must be kept clean, and condensate drain lines must remain unobstructed to prevent internal moisture pooling. The exterior building envelope demands equal attention. Roof gutters must be cleared regularly, and exterior soil must be graded to slope away from the foundation, preventing groundwater accumulation. During new construction or retrofitting, standard paper-backed drywall should be replaced with mold-resistant fiberglass-faced gypsum, specifically in moisture-prone zones. Occupants also play a role through mold-aware habits. Utilizing localized exhaust fans to eliminate transient humidity generated in kitchens and bathrooms cuts off a major indoor moisture supply. True structural defense is not about deploying chemicals to kill mold. It is about engineering an environment so psychrometrically hostile that airborne spores can never break their dormancy. Despite perfect systemic defenses, localized water intrusion events like burst pipes or roof leaks will occur. When they do, the 48-hour response protocol is activated. This chart shows the EPA's official remediation guidelines, which scale protocols directly to the total surface area of the fungal contamination. For small breaches covering less than 10 square feet, the protocol dictates rapid moisture elimination, non-toxic cleaning of hard surfaces, and complete material drying within that critical 48-hour window. However, when the fungal mass exceeds 100 square feet, it is categorized as systemic contamination, and the protocols escalate. Large-scale remediation requires establishing negative air pressure containment zones to prevent spores from escaping, and physically removing heavily degraded porous materials like drywall and insulation. Remediators facing these high spore loads are bound by strict protective equipment requirements, including N95 respirators and full-coverage impermeable suits to prevent inhalation and cross-contamination. Ultimately, mold is merely a biological symptom. Moisture is the true structural disease. Defeating it requires replacing reactive maintenance with a proactive, science-backed moisture management doctrine.